The given problem is find the partial differential equation by eliminating the arbitrary function in the given equation. Z is equal to f of x squared plus y squared plus z squared. Let you take the given equation as equation number 1. Now differentiating the given equation with respect to x. Differentiating with respect to x, we get dou z by dou x, which is equal to, you differentiate the function once, then you differentiate the content inside the function next. The differentiation of the function is f dash of x squared plus y squared plus z squared. Now you differentiate the content inside the bracket. We are differentiating now with respect to x. The first term is x squared. Differentiation of x squared is 2x. When we differentiate with respect to x, y is treated as a constant. The differentiation of y squared is 0. And the third term is z squared. And differentiate z squared once, it is 2z. Then differentiate z with respect to x. Differentiation of z with respect to x is dou z by dou x. And this can be written as p is equal to f dash of x squared plus y squared plus z squared into 2x plus 2z into p. Now differentiate with respect to y. Differentiate with respect to y. Differentiating with respect to y, the given equation becomes, the left hand side is z, dou z by dou y, which is equal to, the right hand side is f of x squared plus y squared plus z squared. First you differentiate the function once, it is f dash of x squared plus y squared plus z squared. Now you differentiate the content inside the bracket. The first term is x squared. When you differentiate with respect to y, x is treated as a constant. The differentiation of x squared is 0. And the differentiation of y squared is 2y. And the third term is z squared. You differentiate z squared once, it is 2z. And then differentiate z with respect to y, it is dou z by dou y. And remodifying this equation, this is q is equal to f dash of x squared plus y squared plus z squared into 2y plus 2z into q. So dou z by dou y is written as q. And let you take this equation number 2 and let you take this equation number 3, and from 3 we get a substitution for f dash of x squared plus y squared plus z squared. It is equal to q divided by 2y plus 2zq. Let this be equation number 4. And substitute 4 in 2. We get p is equal to, you substitute for f dash of x squared plus y squared plus z squared, it is q divided by 2y, q divided by 2y plus 2zq into 2x plus 2zp 2zp, and the right hand side you can cancel the 2, and this is equal to, this is p is equal to q into x plus zp, and this is equal to qx plus pqz plus pqz. And denominator is also there, y plus zq, y plus zq, this is y plus zq, and cross multiplying this, py plus pqz is equal to qx plus pqz, and pqz gets cancelled, and px is equal to, and py is equal to qx, and py is equal to qx. This is the required partial differential equation. Students, the problem given here is obtain the partial differential equation by eliminating the arbitrary function f from x is equal to, from z is equal to xy plus function of x squared plus y squared plus z squared. Obtain the partial differential equation by eliminating the arbitrary function f from z is equal to xy into function of x squared plus y squared plus z squared. Now our duty is to eliminate the arbitrary function. For that, we shall first differentiate the given equation with respect to x and y. Let you take the given equation as number 1. Now when we differentiate the given equation with respect to x, on the right hand side the first term is x into y. When we are differentiating with respect to x, y is treated as a constant, and y into differentiation of x is 1. Next we shall differentiate the function. You have to differentiate the function once, and then you have to differentiate the content inside the function next. And the differentiation of the function is f dash of x squared plus y squared plus z squared, and when you differentiate the content inside the function, it is the differentiation of x squared is 2x. When you differentiate with respect to x, y is treated as a constant, the differentiation of y squared is 0. And now when you differentiate the third term, z squared, z is a function of xy. First differentiate z squared once, then you have to differentiate z. The differentiation of z squared is 2z into the differentiation of z is dou z by dou x. This is written as and remodifying the equation, you get p is equal to y plus f dash of x squared plus y squared plus z squared into 2x plus 2zp. Next, differentiate the given equation with respect to y. And when you differentiate the first term, x is treated as a constant, so x into the differentiation of y is 1. Next, when you go for the differentiation of the function, you differentiate the function once. It is f dash of x squared plus y squared plus z squared, and you differentiate the content inside the bracket. When you differentiate with respect to y, x is treated as a constant, so the differentiation of x squared is 0, the differentiation of y squared is 2y, and the differentiation of z squared is 2z into dou z by dou y. Remodifying this equation, dou z by dou s, dou y is written as q, which is equal to x plus f dash of x squared plus y squared plus z squared into 2y plus 2zq. This is taken as equation number 3. From 3 we have f dash of x squared plus y squared plus z squared is equal to f dash of x squared plus y squared plus z squared is equal to q minus x divided by q. Let this be equation number 4. Substitute 4 in 2. Substituting 4 in 2, we get substituting 4 in 2, we get P is equal to y plus q minus x divided by 2y plus 2zq into 2x plus 2zp. So this is the required partial differential equation. Students, the given problem is form the partial differential equation by eliminating the arbitrary function from x into y into z is equal to x squared plus y squared plus z squared. To solve this problem, let you take the given equation as equation number 1 and differentiating the given equation with respect to x. The right hand side is x into y. When you differentiate with respect to x, y is treated as a constant, and there are two other terms, x and z. Z is a function of x comma y. Y is treated as a constant here, so y is taken outside. Y is taken outside, and the differentiation of x into z, it is of the model u into v model. First u into differentiation of v. So y into u is here x into differentiation of v is z, dou z by dou x, plus v into z into differentiation of x, it is 1. Now you have to clearly understand this. Y is treated as a constant, it is taken outside. X into z is in the uv model, so you have to differentiate x into z in the uv model. U is x, the differentiation of v is dou z by dou x, and v is z, the differentiation of u is x, differentiation of x is 1, which is equal to, when you are differentiating, this is function of, you have to differentiate the function once, phi dash of x squared plus y squared plus z squared into, you have to differentiate the content inside the bracket. It is 2x, first term differentiation, 2x, the differentiation of y squared is 0, the differentiation of z squared is, first you differentiate z squared, it is 2z, into differentiation of z again into dou z by dou x, and this is written as y into xp plus z, which is equal to phi dash of x squared plus y squared plus z squared into 2x plus 2ZP. So this is taken as equation number 2. Now differentiate the given equation with respect to y. X is treated as a constant. Differentiation of y is it is UV model, and first u into differentiation of v, that is z, it is dou z by dou y. Y into dou z by dou y plus v is z into differentiation of y is 1, which is equal to the right hand side 5 dash of x squared plus y squared plus z squared into the differentiation, the content inside the bracket. When you differentiate with respect to y, x is treated as a constant, so x squared is a constant 0. The differentiation of y squared is 2y, and the differentiation of z squared is, differentiate z squared once, it is 2z into dou z by dou y. So rearranging this equation, it is x into yq plus z, which is equal to 5 dash of x square plus y square plus z square into 2y plus 2z plus 2z into q. So this is taken as equation number 3. And from 2 we get a substitution square. So 5 dash of x square plus y square plus z square is equal to y into xp plus z whole divided by 2x plus 2zp, 2x plus 2zp. So let you take this equation number 4, and from 3 we can arrive a substitution for 5 dash of x squared plus y squared. So 5 dash of x squared plus y squared, we are obtaining this from equation number 3, from 3 plus z squared is equal to x into yq plus z whole divided by 2y plus 2zq, 2y plus 2zq. Let you take this equation number 5, and the equation number 4 is dash of x squared plus y squared plus z squared, and 5 also 5 dash of x squared plus y squared plus z squared. So 4 is equal to 5, and you equate these two equations, y into xp plus z whole divided by 2x plus 2zp is equal to x into yq plus z whole divided by 2y plus 2zq. Cross multiplying y into xp plus z into 2y plus 2zq is equal to x into yq plus z into 2x 2x plus 2zp 2zp. So multiply this equation, xyp plus yz into 2y plus 2y plus 2y plus 2zq, which is equal to xyq plus xz into 2x plus 2zp. And now once again multiplying 2 into x y squared p plus y squared z plus 2 into x y into q plus 2 into y z squared q, which is equal to, you multiply the terms in the right hand side, 2x squared yq plus 2x squared z plus 2x y z pq plus 2x z squared p. And rearranging these equations, we get final form as px into x squared plus y squared plus z squared minus qy into z squared plus x squared is equal to z into x squared minus y squared. This is the required partial differential equation. And students, they have to be very careful in solving this problem. Just you procedurally try, differentiate with respect to x and differentiate with respect to y, and 5 dash of x squared plus y squared plus z squared are equated. From this, the final equation is arrived.